Good day. So now we are in the part 2 of our AVR activities. So here are the tasks that we are going to perform in this part, and later on we will try to solve them in this latter part of the video. So I suppose that you already know the drill by the creation of the file. Also, we should establish the location of the file for us to easily find it. So here is our first code, and let's assemble this code first for us to check if there are errors. And as we can see that there is an error, of course. And as we drag this scroll bar, we can see that there is a undefined symbol, which is the R4A, meaning that the register is invalid since the registers that we only had is the register from 0 to 31. That is why we replace it with R21 since it is the only register that is visible in this code. So as we assemble the code, we are successful, meaning there are no errors as we try to change the register of R4A to R21. So let's try to assemble and build this code. So now we had entered the debugging mode. So let me just adjust this one for us to see the status register, which is the C flag, since it is the only one that we are about to examine. So for the first single step, so there are no significant changes with our Z flag. And as we refer to the table below, which is a bitwise operation that we had performed, so in the left part, the R20 is added to the R4A, which is an invalid register. That's why the result is invalid register, and as well as our Z flag. On the right part is the code troubleshooting that we had done, in which the resulting value is not exceeding with the 8-bit value. That's why the C flag is not equal to 1, or it is equal to 0. So I guess that's it for the first part of this task. So now we will proceed to the second part of this task. So here is the code given to us on the second part. So I guess there would be an error, and I guess we will troubleshoot the code if ever it happens. And I am not mistaken, since there is an error, as you can see, undefined symbol R2B after I assemble this code. So we will try to change this register into R17, since R2B is an invalid register and R17 is only the possible and the visible register that we can utilize. So let's try to assemble this code for us to see if there would be an error or not. So as you can see, there are no errors, and we are successful with the troubleshooting of our code. So we can now proceed to the debugging mode. So now we are in the debugging mode, and as you can see, here is our C flag, and this is our status registers. So we will try to single step this code for us to see if there are changes. For the LDI instructions, obviously there would be no significant changes for our C flag since it is just the loading of values. But for the add instruction, I guess there would be. But after the add instruction, as you can see, there are no significant changes with our C flag, meaning that the resulting value of the previous instruction is not resulting or not exceeding to 8 bits. And referring to the bitwise operation below, it is obvious that the Z flag will equals to 0. So I guess that's it for the second part. So let's proceed to the third part of this task. So here is the code given to us, and let's try to assemble this code for us to verify and see if there are errors existing within this code. And as you can see, there are errors. And as we drag this down, no, there is undefined symbol R76. So R76 is an invalid register, so we should replace it with R26 since it is the only possible and visible register for us to utilize. So let's try to assemble this code again, and let us verify if there will be errors within this code. And as you can see, there are no errors. And yeah, assembly complete. So let's try to build and debug this code. So we are in the debugging mode. So here is our status registers, and this is our C flag. So let's try to single step this code. And for the first LDI instructions, there would be no significant changes with our C flag since it is just the loading of the values. And after the add instruction, I guess there would be a significant change depending on the result of the two loaded values in our registers. And as you can see from our status register, the C flag has been turned to 1, meaning that the resulting value in the addition of register R25 and R26 is exceeding the 8 bits. And as you can see to the right part of the table, on the bitwise operations below, there is a carry 1 on the operation after the addition of R25 and R26. And that is the reason why the C flag has a value of 1. And I guess that's it for this third task. So let's now proceed with our last task. So this is the last code that we are going to perform in this task. So let's assemble this code for us to verify if there are errors or no errors in this code. And as you can see, there are no errors within this code. So we can now proceed with the debugging mode, or let's build this code. So now we are in the debugging mode. So here is our status registers as well as our C flag. And we need to single step this program for us to examine them. The LDI instruction does not deal any significant changes since it is the loading of values. However, the INC instructions will try to increment the R25, which is the register that we had loaded a value, and as we try to call the to increment instructions, it will increase the loaded values into the register by 1. More importantly, after the to increment instructions, there is no changes within our C flag, meaning that after the to increment instructions, the resulting values does not exceed to 8 bits. And I guess that's it for this task. See you on the last task.